Hi there, my name is Beyang. I'm the CTO and co-founder of Sourcegraph, and today I'll be sharing a dev's thoughts on developer productivity. So this talk is going to be fairly straightforward. It's going to be centered around really 5 pictures of what developer work looks like. Why draw these pictures in the first place? Well, why draw pictures of systems at all? We do this because we want to model out the behavior of those systems so that we can build intuition as to how they work, and thereby make intelligent decisions about how to optimize the inputs and what outputs to track. We draw pictures of a lot of other systems. We draw pictures of how restaurant work operates, for example, on the far left-hand side of the slide here. We draw pictures about computer systems. The middle picture is a picture of cooperating Go routines in the context of a concurrent and parallel Go program. The picture on the right is a picture of gradient descent, the kind of hill climbing approach, visualizing what's happening as the algorithm takes steps in a state space to optimize some objective function. And then we also draw pictures of things like the customer journey in a particular piece of software or product, modeling out the different nodes and transitions between those nodes from when a new user comes to your product all the way to when they become a paying customer. We draw these pictures because we want to illustrate a mental model of how the system works, because without that mental model, we're basically flying blind. And as every smart computer scientist and programmer knows, optimizing something in a vacuum without the context of what the big picture looks like is a recipe for disaster. So one of the motivations for this talk, I'd say the primary motivation, is the observation that there aren't too many of these sorts of pictures that attempt to illustrate what developer work looks like. I think the really the only prevailing picture of what software development looks like is the picture of the SDLC, the software development lifecycle. You probably are familiar with this picture. It's a mainstay of any sort of marketing material in a company that targets developers. There's typically 6 to 8 stages, depending on how you break things down. There's a planning stage, there's an authoring stage where you write the code, there's a reviewing and test stage, there's a deployment stage, and then there's some stages devoted to operating the software in a production environment, measuring and reacting to state changes in production. And this is a reasonable picture of the overall kind of dev cycle. But the issue with it is that it's primarily an ops-focused picture, meaning it focuses on the operational aspects of deploying and running software. But what's kind of missing is what I think of, and I think many other developers would agree, is really the heart of software development. The heart of software development is really about creating source code, writing source code, combining various algorithms and data structures and system designs and architectures into a working piece of software that does a certain task or helps users complete a certain task more efficiently. And really, this heart of software development is something that's not really captured by any prevailing, picture. And so I wanted to try to include that into the main primary image of software development in some way. And so what I came up with is there ought to be an inner loop that's embedded within this outer loop of the SDLC. And the inner loop is where all the interesting stuff happens. It's where you come up with novel system designs. It's where you come up with, the abstraction pattern, the set of interfaces that define the boundaries of the software. It's where you write all the functions, the for loops, the conditionals, all that good stuff. And really, the inner loop is kind of this tight loop that's invoked at various stages in the outer loop. Obviously, in the authoring stage, it's mainly in the inner loop, writing code. But in the planning phase, there's a lot of context that you need to acquire that requires diving into the source code. In the reviewing stage, you're jumping into a new piece of code that's just been written, trying to make sense of what's going on. And in the production stages, you're reacting to perhaps like a site outage or a spike in some performance metric. And there again, you have to dive into the source, understand what the root cause of that spike is, and make an update to the source code. This all requires going back to that critical inner loop of software development. This is essentially the same picture, even though it doesn't look like it. What we've done here is rolled the outer loop out into a linear progression. That's the purple in the middle there. And then the inner loop is the orange at the bottom. And this is just a way of visualizing the transition states between the outer and the inner loop. And at the very top here, you have kind of the production change log. This is like the official upgrades and deployments to whatever your production environment look like. So you have this linear chain at the top, but then of course, all this stuff that happens in a given patch set or in a given feature that you're trying to implement in the middle and bottom layers. And the thing I like to think about in this variant of the picture is that software development often is this kind of game of chutes and ladders, so to speak, where you're constantly trying to make forward progress and get to the point where you can make a good update to production. But at any stage in the outer loop, you might need to fall back into the inner loop. And once you fall back into the inner loop, you might realize something that takes you all the way back to that very first stage. Who among us has not gotten to the point where, we cleaned up the code that we're working on, we've written a bunch of tests, submitted it for review, and then someone points out a key architectural assumption or maybe some library that already exists that we ought to be reusing. And then we have to go back to the drawing board and rewrite a bunch of work. And I think laying out the picture like this really illustrates how that happens in practice in a way that I don't think is quite captured in the SDLC picture of software development. Another picture that I think is really important is visualizing the process of getting into flow state as a software developer. So someone who is in flow state is someone who has been able to achieve a certain amount of focus. It's that magical state of mind where all the context that you need to code at the speed of thought is sort of paged into the L1 cache of your brain. And you're operating at kind of peak productivity. I think every developer knows viscerally what this feels like. It's when, those late nights when you're up coding or you have a long interrupted block of time and you're really able to dive into the meat of whatever problem that you're working on at the moment. But the reality of software development day to day for a lot of folks is very often we get interrupted before we're able to reach flow state. And each interruption kind of resets our progress back to this zero line. And I think this is a very important picture to keep in mind, especially when communicating the nature of developer work to non-developers, because this might not be counterintuitive. Naively, you might assume that the cost of a context switch is zero, or the cost of an interruption is just the time it takes to address the interruption, and not accounting for the time it takes back to ramp up into flow state. But developer productivity is not just a scalar value. It's really kind of this multi-dimensional thing where it's not just the size of the step that you're taking or the quote unquote speed at which you're operating. It's really also the direction that you're taking that matters as well. So this leads us to this picture, which has a ton going on in it, but the basic gist of this visualization is trying to model out the overall journey of software development as kind of this like vector sum. So kind of similar to that gradient descent picture from a couple slides back, modeling out the optimization algorithm that a lot of machine learning models take these days. Software development is also taking steps in a state space. That space is the space of possible code. So all the kind of compilable versions of your code base are a point in the space. And when you make an update to the code base, you're basically taking a step in that space, hoping to optimize some notion of user value. And often the journey is not very linear because it's not obvious in which direction you can step or how big a step you should take in order to yield a reliable improvement in user value. And so I wanted to kind of draw that out and mark out the entire journey. You can kind of think of like your developer velocity, the amount of time you spend in flow state as comprising maybe like a scalar component of the vector. So like the size of the vector is tied to the speed at which you're able to move. But the directionality is really the design decisions that you decide to make, the various product decisions that you make as an engineer or product manager, and these all influence the value that you're producing at the end of the day, which is really the value that you're providing to users of the software. And we can kind of embed the inner and outer loop into this picture as well, whereas where each arrow in this picture, each big arrow is maybe like one iteration of the outer loop, the SDLC iteration loop. But that in turn is broken down into many editions of this inner loop, because you're probably doing many iterations on the source code for each eventual patch that you make to the production state of the software. One thing that we haven't covered yet is the team collaboration element of software development. So in today's world, very little software is developed by a single individual alone. There's often team members or external collaborators. And one way to visualize the value of working on a team is doing this kind of addition of the different productivity graphs of the individuals comprising that team. So, individual productivity is very choppy. We all have good days, bad days, sometimes good weeks, bad weeks, or even, good months and bad months. And what the team combination does is smooth out that volatility so that a team should be able to more robustly move at a predictable pace over time. There's also kind of the productivity gain of being able to add these up, but as we'll touch upon in just a moment, that additive productivity boost is not always linear. As you scale the number of people on a team, you don't always get a linear boost in overall productivity. Sometimes it even goes down, but what you do get is a boost in kind of predictability and robustness. So diving into the trade-offs of teamwork a little bit more. So why don't we get just a linear scaling of productivity the more people we add to a software team? Well, one way to visualize this is if you think about building software as kind of like building up this pyramid of bricks over time, where you have to lay some things on the bottom first. Some pieces have to go on the bottom before you can lay the ones in the middle and on the top. And then there's different domain areas that each of these pieces touches upon. One might be an infrastructure component, one might be a front-end component. And so there's these dependencies that you have to reason about. And so if you think about one developer working, the downside of one developer working is maybe there's some component that needs to be built where they don't have domain knowledge. And so consequently, that purple piece is unfamiliar code. If you embed the kind of like flow state graph of that person into that piece, it's going to be this kind of like sawtooth pattern, because there's going to be a lot of context switching to pick up new knowledge that's necessary to work in an unfamiliar domain. And so that's bad. We might be tempted to augment this individual by adding another person into the mix, someone who has domain knowledge about other areas of code. But here we find that the serial dependencies kind of get in the way. Sometimes one person, the piece that they're working on depends on the piece that someone else is working on. And so they have to block until that person's finished. Sometimes when you have multiple people in the mix, you can actually run into situations where it's more likely that someone will have to work on an unfamiliar piece of code, just because there's more code to work on and there's more opportunities to do these like poor allocations of people to domain areas. And so I think like the idea behind this picture is really to just try to sketch this out a little bit, similar to the kind of concurrent Go routine execution diagram from one of the first slides in the slide deck, just illustrating out what concurrent software development looks like, so that we can better reason about the impact of serial dependencies and domain knowledge on the overall pace of software development. So that's it for the talk. Really, as promised, it's a very simple, straightforward talk, just trying to draw 5 simple pictures that maybe model or shed light on the nature of software development a little bit more than the pictures that we have. Again, this is not meant to be like a comprehensive worldview or ideology or framework about how to do software development. It's really just an attempt to model out more of the world that we live in, so that we can better understand it and make more intelligent decisions. So I want to end with a prompt here to those of you listening. Having looked at that, I'm sure some of you, there might have been stuff that you agreed with, and probably stuff that you strongly disagreed with. What pictures would you draw to model your own work as a software developer? I think it's important, especially as we see the developer tooling landscape evolve and you see more and more products come on the market that are targeted at boosting developer productivity, that we have developer voices in the mix, keeping people honest about the nature of the work, and that there's a healthy ongoing conversation about what does software development actually look like? If we were to model the system out, what does that picture look like? And how can we, as a kind of collective community of software craftspeople, how can we make that system evolve for the better? That's it for my talk. If you want to continue this conversation, you can come find me on Twitter. I'm just at Beyang, or you can go to this link to join the Sourcegraph community Discord. We're all developer tooling and productivity nerds, and would love to chat about this with people who share that interest and passion.